go? No, like, how does it go?
Dab? You like it. Oh.
Dab?
Okay.
No, it's like it. It's like it.
Okay, next time. All right. So we have to start. Long division and synthetic division, the remainder theorem, and the factor theorem. Okay? For f of x equals 6x minus 3 minus 19x squared plus 16x minus 4, 2 is a 0. Use the long division to find the other factors and zeros. Okay? So I'm going to show you how to do this using long division, and then I'm going to show you how to do this using synthetic division, which is way quicker. Okay?
Factor.
But, well, that one, could you factor that? Maybe you could try factor by grouping. I don't think it would work, okay?
Oh, okay.
So, and this one actually, I think, has a remainder. So, I'm not sure. We'll work through it and see what happens, okay? So, if I am doing long division, okay, first of all, why am I putting a square root thing? Okay. If 2 is a 0, that means that x minus 2 is a factor, right? So I'm going to divide x minus 2 into this thing, okay? 6x cubed, just like you're doing long division with regular numbers, okay? 16x minus 4. And now the other thing to remember when you're doing long division and synthetic division, these have to decrease by 1 degree each time. So if there's no x squared term, you have to write like 0x squared. And if there's no x term, you have to write like 0x and minus 4 and so on. So this is the way you do it. Anyone know how to do this? Oh, good. Good. I'll teach you something. So what you want to do is you want to turn this x into a 6x cubed. What do I need to multiply x by to turn it into a 6x cubed? 6x squared. So you want to multiply this by 6x squared, and you line up your like degrees, okay? So the x squared, you're going to put a 6x squared up here, okay? Now, just like you do when you do long division, you multiply this times this, so that gives you 6x cubed, and what's 6x squared times negative 2? Minus 12x squared. And just like you do with long division, you do what?
Wait, where do you get the 6x squared?
I multiplied, because I want to turn this x, my leading term of my, the divisor, okay, into 6x cubed, because I'm going to subtract it. That's what I do next. I subtract this entire thing from that. Okay, so you got to remember that you're subtracting the whole thing, otherwise you're going to end up with messed up signs. So 6x cubed minus 6x cubed disappears. Negative 19x squared minus negative 12x squared makes how many x squareds?
7.
Negative 7x squared. And that goes down there. Just like you do with the long division, you bring down the next thing, okay? Which is plus 16x. And then I say, what do I need to multiply x by to turn it into negative 7x squared? Negative 7x. And that goes above the x term over here, okay? So multiply this times this. That gives you negative 7x squared. That's why I did it, to make these two things the same so I can subtract. And this times this makes positive 14x. Now I draw a little line and I subtract again. Remember that you're subtracting the whole thing. So this goes away. 16x minus 14x makes 2x. Bring down the negative 4. Okay? And then I say how many times, what do I need to multiply x by to make it into 2x? 2. Okay? So then I put a plus 2 up here. And that makes 2x minus 4. And then when I subtract, what do I get? 0. So that means that x minus 2 goes evenly into this thing. And this is called the quotient, right? Quotient. I think dividend, I always get those words confused. Dividend, divisor, I think. But it comes up in the next slide. So, but that's your quotient. So if I went in reverse, that means that 6x squared minus 7x times x minus 2. So that means that x minus 2 times 6x squared minus 7x plus 2 is equal to this, right? Because the opposite of division is multiplication. So if I multiply this times this, I get this, right? Then I have to factor this, okay? So how do I factor that? You guys know how to factor that?
Yeah.
Do you know the Mrs. Voss method?
No.
The cross and box method? You guys learn the cross and box method? So when you don't have to do it this way like most people.
-3 and -4.
No.
X minus 3. X minus
You know that here you have to have a 2 and here you have to have a 1, right? Because, or in one place has to be 1 because it has to multiply to 2, right?
Yes.
Then, you know you're going to have some minus signs, right? And I think it goes like this: 3x, 2x, 2x, minus. Yeah, well, there's another way to do it, but
Are they both minus? Yeah.
yeah, because this makes
Yeah,
no,
yeah.
that's not right. Because that makes minus 2x, and that makes minus 6x, which gives you minus x 8x. So you have to flip those around, I believe, right? Let's see what happens then. So I'm guessing and checking. If I put that in -2, that works, right? And make this one a -1.
That's what.
Okay? Then it works. Okay? Because this times this gives you 6x squared, this times this gives you -4x, that gives you -3x, and this times this gives you 2. So use long division to find the other factors and zeros. So these are the other factors. The other zeros, if I drew a little squiggly line, are x equals 2/3 and x equals 1/2. And here's your x equals 2. Okay? You do have to know how to factor a quadratic. However you choose to do it, you can. Okay? Questions?
Is it x equal to negative?
No, because you set this equal to 0, right? 3x minus 2 equals 0.
Yeah.
So x equals positive 2.
Gotcha.
All right? Okay. More? More, right?
No.
Yes, please, more. I did that one already. Okay, so the thing that you are dividing into, here's the words. That is called the dividend, okay? That's like this divided by, the thing that you are dividing into that thing is called the divisor, and the thing that you get is called the quotient, and then you have a remainder. So, for instance, we're going to do something kind of that you might remember from when you were young. Okay, 8 goes into 25. Okay, 28. I wrote. Oh well, let's go 8 into 28. How many times does 8 go into 28?
4. The
3 times, right? And 3 times 8 is 24. With how much left over? Remainder 4. Okay, so what this says over here, if I multiply the divisor, which is 8, times the quotient, which is 3, and add the remainder, I get the dividend, right? So in other words, 8, to put it in this form, 28 is equal to the divisor, which is 8, times the quotient, times 3, plus 4. Would you agree with me there?
Yeah.
Okay. Conversely, or this means the same. I mean, it looks way more complicated than that. But all this means is that 28 divided by 3 is equal to 8 plus 4 divided by is equal to 3 plus. Sorry. That's is equal to 3 plus 4 divided by 8, right? So 28 thirds goes in 3 and 4/8. So sometimes you could write it like this, means the same thing. So 28 divided by 3. So basically I'm dividing everything by 3 up here, or by 8, sorry. Dividing everything by 8. Oh,
Yeah, that should be an 8.
That should be an 8. I'm sorry.
Right.
That should be an 8. Easy to fix. 28 divided by 8 is 3 and 4/8. So now we're going to do that with
What is it?
algebraic, what?
Oh,
It's
no,
not?
It is.
3 and 4/8, isn't it? Goes in there 3 times with 4 remaining. Alright? 3 and a half?
Yes.
Same thing. Alright, so now we get to do this. Divide this by this. And you go, no, I'm not doing that. So you could just say no and be done. Can't do that.
No.
So let's do that. Wait, going back.
It's just
No, we're okay.
no.
Yeah.
You have to write down the division algorithm.
What?
You have to write down the division algorithm.
I don't think so. I mean, you could just kind of know it. So if I were to divide this by this, watch. This is, so first of all, when you divide things, you have to, so I'm dividing this big expression by that big expression. I have to arrange them from highest degree down to lowest degree. Okay, so I'm going to divide 2x to the 4th, it's not as bad as it looks, plus 4x cubed plus 5x squared. Nope, it's minus 5x squared. Minus 5x squared plus 5x squared plus 3x minus 2. And I'm going to divide that by x squared plus 2x minus 3. Okay? So, who can tell me what I multiply by first? X, 2x squared, and it goes up here, right? So I'm going to put a 2x squared up.
Why does it go above?
Because you want to keep the degree lined up, okay? So 2x squared goes here, so this times this gives you 2x to the 4 plus 4x to the 3. Oh, that's nice. Minus 6x to the 2, and then I subtract that entire thing from this thing, okay? So that goes away, and what do I have here? Minus 5 minus
1x.
1 is just plain old x squared, okay? Now, because this thing has 2 terms, I'm going to bring down both of these, okay? Plus 3x, and I'm going to bring down the minus 2. Okay, because I can. What do I multiply by next? 1. X, right? No, just 1, right? No, there's nothing to multiply by here, so I'm going to put the 1 over here. Yes? 1 times that makes x squared.
Is it plus 1 then?
Yeah, plus 1. So, and 2x goes here, plus 2x, and minus 3 goes here. And then I subtract again, okay? And this goes away, this becomes x, this,
Oh.
and minus 2 minus minus 3 makes 1, okay? Will this go into here? No, so this is my remainder, okay? So this is R, okay? So, so then you can you can rewrite this as x squared plus, not right, that this big thing is equals x squared plus 2x minus 3 times 2x squared plus 1 plus what? X plus 1. Okay? This is the same as saying, I don't want to go there. I'm going to just leave it like, well, I could. This is the same as saying that 2x to the 4th minus 4x cubed minus 5x squared plus 3x minus 2 divided by x squared plus 2x minus 3 is equal to, okay, 2x squared plus 1 plus x plus 1 over x squared plus 2x minus 3. So this is another way to write the same result. What? Where's plus 4x? Oh, plus 4x. Okay?
That's the point.
Okay?
That's
So-
magical. That's life changing.
Isn't that life changing? Good. All right. So now we're going to move on to. You want me to show you that for some more time? There you go. Whoa, you can't see that? We're going to pause. Hit play. Use synthetic division to divide this by this. So synthetic division is really nice. You take, if this is plus, you divide by a negative. Okay? This is the algorithm. Do you understand that algorithm? No, you don't. All right. So, how many of you done synthetic division before? So, oh, wow. Okay. So,
That's here.
and it just uses, someone figured out that, well, I could just use the coefficients of an expression rather than just do it. So if this is plus, in a little, the way I do it, I put a little box out here. They do the box like this. I kind of put the number, I put negative 3 over here because it's x minus k, okay? And so k would be negative 3 in this case, so it means the root, or the factor is x plus 3, which means the root or the 0 that you're dividing into this, or you're trying to see if it goes in evenly, is negative 3. And then you put the coefficients of the expression next to it, okay? So notice this, 1, what comes next? Yeah, it does not come next, okay? Because there's no x cubed term, so you have to put a 0 as kind of a placeholder for your x cubed term, okay? Then you go minus 10. Then you go minus 2. And then you go plus 4.
So it's kind of like matrices?
No, it's way easier than okay? So,
But then again, it's the same.
so then what you do, it's just like you have to know how to do it, know the algorithm. You bring this straight, you bring that 1 straight down to the bottom, okay? You multiply negative 3 times 1, and you put that result right here, okay? Then you add, okay? I'm going to add this plus this and give me negative 3.
You multiply.
Then I multiply again. This times this, 9. Then I add negative 1. This times this gives you 3. Then I add, I get 1. This times this gives you negative 3. Okay? And then I add, and this is 1. This here is your remainder. Okay? This is the reduced polynomial expression. So what this means is this thing is equal to, if I divide x plus 3 into here, this is equal to x plus 3 times this, okay? X, this is, the degree goes down. So where this was x to the 4th before, I reduced the degree by 1. So now it's x cubed minus 3x squared minus x plus 1, remainder 1. Okay? That's how you would do that.
Then you use synthetic division to divide that. You use
If this was a factor, but in this case we just shown that x plus 3 is not a factor, because if it were a factor, this number here would be 0. Okay? Which is what we're doing next. Okay? But first,
Yeah.
What is that?
That's how I feel.
this is my old dog, Otis. Otis passed away.
Oh.
Sorry.
Now we have a new dog. I'll get him up there pretty soon. He's really cute, Cody.
Yes.
But Otis, he was a professional dog model. And just kidding. But this was his favorite position on the couch.
Oh,
Isn't he cute? Poor Otis.
How'd he die? What?
I don't know. Yeah, he just, I don't know what happened. Use the remainder theorem to find f of 1, okay? So first we're just going to use synthetic division to find f of 1. Then we're going to use the remainder theorem to find f of 1, okay? So if I use synthetic division and 1 is a factor, okay? I'm going to go 1, -2. I just want to show you this fast. -4 and 1, right? There's nothing in between those terms. So bring this straight down. Good. I get 1. This times this gives you
No.
1. This plus this gives you
One.
-1. This times this is
Negative one.
-1. This plus this is
-5.
-5. Oh, and this times this is -5. And then you get -4. What the remainder theorem says, okay, is that, so this would be a remainder. What the remainder theorem says is that this remainder, if I took and divided this polynomial by x minus 1, I would get a remainder of -4. What the remainder theorem says, another way to find that remainder is just to take -4 and plug it in for x, and I should get, not -4, take 1 and plug it in for x, and I should get out -4. Watch. 1 f of 1, right, is equal to 1 cubed minus 2 times 1 squared minus 4 times 1 plus 1. And if you did all that out, you would get -4. That's what the remainder theorem says.
So no matter what you plug in 1.
No, you plug in, if you want to divide by x minus 1 and see what the remainder is, you would plug in 1. If you want to see what the remainder is, if you want to see if x plus 3 goes in,
-3.
you would plug in -3. But the real reason you use this is to see if that number is a root of your equation, okay? So if this number ends up being 0, then you know that it's a factor, right? So if I plugged in a number and it came out to be 0, then I know that that number would be a factor. For instance, next thing, promise, next to last thing. This is what this says. Factor theorem. If f of k is equal to 0, then x minus k is a factor. Show that x minus 2 and x plus 3 are factors of this. Okay, one more time. This is the last one. Promise. Okay? So you write the numbers 2, 7, -4, -27, and -18. What goes out here in the box? 2 or -3. Doesn't matter which one you divide out first. You'll still get the same answer. Okay? And then you bring this 2 straight down. So you get 2. 2 times 2 is 4. Add those, you get 11. This times this makes 22. You're saying, oh, this doesn't look good. Add those together, you get 18. 2 times 18 is 36. Add those together, you get 9. 2 times 9 is 18. What do you get out? 0. Okay? So what that means is that x minus 2 is a factor, 2 is a root. Okay? Then I do it again, but I do it on this part. You see? Okay? What goes out here? Now I'm going to, so.
Why do you do it on that part?
Because so far what I've done when I divided this is I factored this to, I factored out an x minus 2 times 2x cubed plus 11x squared plus 18x plus 9, right? That's what I've done so far. Okay? Then I could factor the cubic by doing a -3, right?
Okay.
And so bring the 2 straight down. -6, 5. I'm going fast. -15, I think, 3. -9, right? 0. So now what I've broken this down to is x minus 2 times x plus 3 times 2x squared plus 5x plus 3. This thing factors some more, and tomorrow you'll learn how to find which numbers to try. But I think you could factor this 2x and x, and a 3 and a 1. Where does the 3 go? Where does the 1 go?
It should be 3 on the right side.
No, 3 on the left side, right? 3 times this gives you 3x, this times this gives you 2x, and now it's completely factored. Okay, so now it's completely factored, which means that you have zeros at 2, negative 3, negative 3 over 2, and at negative 1. So if I were going to graph this thing just real quick, okay, if I were going to graph it, I'd have a 0 at 2, I'd have a 0 at negative 3, I'd have a 0 at negative 1.5, I'd have a 0 at negative 1. I also know, since a fourth degree, how does it go? Where does it start? It looks like a W, okay? And I don't have any double roots, so it kind of starts up, goes like that, and ends up too. Okay? So that's what that one would look like if you okay?
Shouldn't one of them bounce or?
No, because there's no doubles. If there were a square, then it would bounce, right? If it's a cubic, it goes through. I have a good activity for that. Where do we should do the good activity?
No, we should just start homework.
Wait. Homework.
Yeah.
Homework. What does that say? What does that say? No, he's not though. I saw him. He works at the 7-Eleven in Lafayette. Elvis. He was wearing these glasses when I saw him. So thank you very much. Ladies and gentlemen. You know Elvis?
You love him. Never met him.
Oh, sorry. Oh, sometimes I get. Okay, that's the end.
Yay.
Thank you very much. I don't know how to stop it. Here we go. Close.